Function notation is just a different way to write y equals mx plus b. By naming a linear function f, you can also write the function using f of x equals mx plus b. It's the same thing as y equals mx plus b. The language and notation has changed, but the process of evaluating has not. So if you're looking at evaluating one, if you have evaluate f of x equals negative 4x plus 7, when x is negative 4, 0, and 3, this over here represents the value of the function for the x input. So if I'm saying like f of x is negative 4, x's value is negative 4, it's just a different way to write a linear equation by substituting negative 4 in where you see x in both spots. So you find the function of negative 4 then will be 23. It's the same as saying y equals 4x plus 7 and then finding the value of y. Instead of writing y, we just write the function of negative 4. We write that function of x. So you can use that for every single one of these numbers. So you can see the function of 0 is 7, the function of 3 is negative 5. Its output is negative 5. So when the input is 3, the output is negative 5. So down here you see the next two examples. You can do yours on your own by finding if f of x equals 2x minus 5 when x equals negative 4, 0, and 3. You can plug it in, say like the function of negative 4 is 12. The function of 0 is negative 4. Just a different way to write it. The language and notation has changed, but the process of evaluating has not. So the next piece says then when you solve a function for an independent variable, this is kind of going a little bit differently. It's saying the function of x equals 6x plus 9. And this time it's saying the function of x is 21. So what you're looking to find is, oh, okay, so if the function of x is 21, well, what is that x value that corresponds with that function of x? Because remember, function of x can also be written as your y. Y equals 6x plus 9. Y for y is 21. Well, then you'd be finding out what x's value. So when you figure out what your x value is, you write your solution as that ordered pair. So you'll find the function of 2 is 21. So make sure that you're saying, so since x is 2, the ordered pair is 2, 21. It's not the function of 21 that's 2, it's the function of 2 that's 21. We don't have to use f, we can use g, you can use h, and you can call them like f of x, g of x, h of x, whatever you want to call it. So we've seen how to evaluate it when you're saying like the function of 6 and then you're figuring out what the y value is for that, or the function of 6 is going to output. We've seen when you have the output and you want to find out what the input is going to be. And now we can look at it as saying, okay, well, I can graph a linear function that is in function notation. So if it's f of x equals 3x plus 2, it's the same exact thing as saying y equals 3x plus 2. So you simply graph it. This one is the same thing as saying y equals negative 3/4 x minus 1. Graph your y-intercept, graph your slope, and play connect the dots. So function notation is just simply a different way to write a linear function. The notation has changed, the way you say it has changed, but the process has not. It's all the same as everything we've done before.